So now let's talk about the acid ionization constant. Right? If you have a reaction where an acid, a Bronsted acid, a proton donor, donates a proton to water, for example, ammonium ion donates a proton to water, that gives you NH3, and what happens to the H? It becomes H3O plus, right? Anytime you have this type of reaction, something plus water, and the something donates the proton to the water. That means the water is acting as a base, right? So that something must be acting as an acid. That reaction is called the ionization of the acid. The KEQ for that is called the Ka of the acid. So if HX is the acid, okay, what would be the reaction we're talking about here? We're talking about the transfer of H plus from the acid to water gives you H3O plus, and what's left behind? It's just going to be X minus. Okay? So this reaction right here, ammonium plus water gives you H3O plus and ammonia. Okay? And you can abbreviate this as this one. You can leave out the water and you can just write H3O plus as H plus. That would be an abbreviation for that reaction. Okay? What do you notice is the product of this reaction? And you have, anytime you have an acid donating to water, okay, you get the conjugate base of the acid. What's the conjugate base of ammonium? That's what you get when it's lost the H plus. What happens when you lost the H plus from NH4 plus? Instead of 4 hydrogens, you have 3 hydrogens, right? And you have your charge, instead of plus 1, will drop down to 0. So NH3 is the conjugate base. So in this particular example, you can see that your acid, ammonium, reacts with water to give you its conjugate base, which is ammonia. Water gains a proton, produces it, and you get the hydronium ion, its conjugate acid. So in the acid ionization, you have a reaction with water that leads to the formation of H3O plus. Okay, so the KEQ for that, the equilibrium constant for that, is called the Ka of the acid. So what's the reaction for which the KEQ is called the Ka of HCO3 minus? So if it's Ka, that means it's acting as an acid. What do we say an acid is? A proton donor. So we want this to behave like an acid. So it has to donate a proton to whom? Or to what? Water. Okay. So anytime you have Ka of something, it's something plus water, and it's something, the something is behaving like an acid, so what happens to it? Loses an H plus. So when HCO3 minus loses an H plus, what's left behind? CO3, but what's the charge now? Instead of -1, it's now -2. It's lost another plus charge, so it's now -2. And what happens to your water? H3O plus. Okay, always make that, you always end up with that product right there, the conjugate base of the acid and hydronium ion. So this is the reaction for which the equilibrium constant is called the Ka of HCO3 minus. Okay, how can we abbreviate this? You can leave out the water and you can just abbreviate this as H plus. So you can say HCO3 minus yields carbonate plus H plus. Okay. What's the expression for Ka for this? The equilibrium constant. Ka then is equal to what? The Ka of bicarbonate ion would be concentration of carbonate times concentration of H plus over this products over reactants, right? Over concentration of HCO3 minus. That's it. Provided those numbers, the values are at equilibrium. Okay. Otherwise, it's called your reaction quotient, right? So, yeah. Which of the following is the expression for Ka of HCO3 minus? Okay, very good. What's the conjugate base of HCO3 minus? The conjugate base is what you get if you behave like an acid, right? If you behave like an acid, you end up being the conjugate base. So that's what you get after you've lost your proton. Carbonate ion, very good.